let's talk about some of the properties of triangles that you should be familiar with. There's a whole bunch of them. It can be hard to keep them straight sometimes. So let's go through slowly. Let's kind of review what we know about these triangles. The first property we want to talk about is the midsegment. The midsegment is constructed by drawing a segment between two midpoints of a triangle. In this triangle here, we have a midpoint on this side and a midpoint on this side. We connect them, and that's called the midsegment. A couple of important properties that you want to remember. First of all, the midsegment is parallel to the third side of the triangle, meaning this is parallel to this. It's also true that the midsegment is half the length of the third side of the triangle, and sure enough, this segment is 5, this segment is 10. Let's take a look at some more complex ideas here. First of all, it's important to know what concurrent lines are. Concurrent lines are basically 3 or more lines that intersect in one point. And that point where they intersect is called the point of concurrency. The medians are simply segments drawn from the vertex of a triangle to the midpoint of the opposite side. So we have here the vertex, here's the midpoint, and there's the segment connecting them. Notice that the midpoint will help us to know that we have a congruent piece here and a congruent piece here because of that midpoint. Now, when we have all 3 medians drawn, they intersect at a common point called the centroid. The centroid is right here in this triangle, and it's formed again by all 3 medians. They intersect in one place. The very cool property that comes with the medians is that the distance from the vertex to the centroid is twice as long as the distance from the centroid to the side of the triangle. They're in a 2-to-1 ratio. If from the centroid to the side of the triangle is 5 units, it's 10 units from the centroid to the vertex. Now let's talk about angle bisectors. We know that an angle bisector is simply a segment drawn. It cuts an angle into 2 congruent pieces. When we have all 3 angle bisectors constructed in a triangle, they intersect at a common point known as the incenter. Here we have the purple segment, which is bisecting this angle, the green segment, which is bisecting this angle, and the blue segment, which is bisecting this angle. The red point is the point of concurrency. That's called the incenter. The important property that you want to know about the incenter is the incenter is equidistant, or the same distance, from each of the 3 sides. If it is 5 units from the incenter to the side of the triangle here, it's also 5 units from here to this side and from here to this side. That's the important property that you want to know. It can really help you in solving quite a few problems. Let's take a look at the perpendicular bisectors. We know that a perpendicular forms a 90-degree angle, and we know that a bisector cuts something in half into 2 equal or 2 congruent pieces. A perpendicular bisector simply cuts something in half through its midpoint and forms a 90-degree angle where it intersects. If we have a triangle and we construct all 3 perpendicular bisectors, we have something that looks like this. We have the red perpendicular bisector here, the blue one here, and the green one here. That point of concurrency where all 3 intersect is called the circumcenter. Now, this is a little different than the others because the circumcenter can be inside the triangle or outside the triangle. The special property with the circumcenter is that it's the same distance from that point of concurrency, the circumcenter, to each of the angles. So if it's 5 units from the circumcenter to this vertex, it's also 5 from that circumcenter to this vertex, and from this to here. So that's very helpful in determining ratios in pieces of triangles. Finally, we have altitudes. Altitudes are constructed by drawing a line straight down from a vertex to the other side of the triangle, the opposite side, so that it forms a 90-degree angle. An altitude is basically like the height of a triangle. When we learn area in middle school, we talk 1/2 base times height. The height is the altitude. If we look at this triangle here, we draw straight down to form a perpendicular. Same thing's true down here. We draw straight down to form a perpendicular. Notice that the altitude can be inside or outside of the triangle. When all three altitudes intersect, we call that point the orthocenter. The orthocenter can be inside or outside of the triangle, very much like the circumcenter could. There are no real special properties to talk about this one, but it's worth noting that it can be inside or outside, and it's formed by the altitudes. This concludes our review of triangle properties and points of concurrency.